I'm Charles McFarlane, Chief Business Officer for Codeplay Software. I don't ask any technical questions later. I look after sales, marketing, and business development, but hopefully I can cover enough technical discussion here for you. So, to set the scene, first of all, you've got this very high-level hierarchy here. So you've got CPU and offload accelerators at the bottom. The accelerators at the bottom, there we go. So that CPU can be RISC-V CPU, it can be x86 ARM CPU, and then the offload accelerators. The talk today will cover any accelerator you want there, but you've got a lot of today. I will focus on RISC-V vector accelerators using RVV, the vector extension. You've got this low-level software here, OSs, RTOSs, low-level compilers, LLVM, and OpenCL comes in there. Then this middle layer, we'll talk a chunk about that, where you've got C++ programming, SYCL is a Khronos open standard, and some libraries in there like DNNs, BLAST libraries. And then up the top, linking it together, you've got the frameworks, algorithms, applications that you are wanting to run on this system. We'll talk about, hang on, go to the next one. So the two areas I really want to focus on here. First of all, this area here, the software that will sit on top of your RISC-V accelerator. We call it the OneAPI construction kit. And then secondly, I'll talk about UXL, it's a Unified Acceleration Foundation. Formerly, it's OneAPI, and I'll explain the difference between OneAPI and UXL as we go forward. So first things first, what is that OneAPI construction kit? So the vision of it, it's based on open standards. Everything we do, we use open standards wherever possible. Khronos open standards, OpenCL, SPIR-V for the intermediate representation. SYCL is a high-level C++ programming environment. So we use open standards wherever possible. There's already, with OneAPI, a whole ecosystem of libraries, of ports, of tools already there, so you can take advantage of that. A lot of people are already using it. So there's a wealth of material already out there. And then the third part there, we've taken SYCL as that programming environment. So we've enabled SYCL with all that OneAPI ecosystem there, and we've got that running on a RISC-V accelerator with vectors, with the vector extension. So what are the benefits of all of this? Okay, so it brings OneAPI to your hardware. There's a lot of demand for standards to get that ecosystem there, and you want to do it quickly. And when many people are using it, if you're doing an AI accelerator, a RISC-V accelerator, it gives you rapid access up to that. And developers like the continuity of standards, and it will be around for a long time. What we've created is substantial tutorials. We've done two things actually with the construction kit. We've simplified it. Historically, we used to do this Codeplay ourselves. We used to take people's accelerators and we used to do all this porting ourselves. We've massively simplified it and documented it. So there's lots of material there in tutorials how to do this. And to make it even simpler for RISC-V, we've got a reference implementation based on the RISC-V with a vector extension, so that it shows you how you will offload your code and run these kernels onto that accelerator. And there's a few components in there that are very critical for that low-level software. The vectorization, so that if it comes from a single scalar code, it will vectorize that so that it will parallelize it onto the accelerator, your vector accelerator. And the math libraries that are in there. Mathlibs are, we used to do them, that was part of our OpenCL implementation, so it's done to a very high degree of accuracy, and it's built into the OpenCL specification, so that is available in the construction kit as well. So how do you get there? You start off with your accelerator. Remember, this could be any accelerator, but specifically for RISC-V, you start off with your accelerator, and you want to get up to the right-hand side of that code, of that picture there, where you've got a full stack of software. So you start off on the left-hand side here, where you run 5 basic APIs. You just have to get these 5 basic ones up and running, and it's using a unit we call Click, and we give that away for free, and you just go and port your software and make sure that you've got these 5 operations running there. You then get your LLVM. Now, a lot of companies actually, that is a starting point with accelerators, so a lot of companies already have some LLVM working on their system. Even though you've got a full LLVM working, you need to do 1 or 2 tweaks and 1 or 2 hooks to get into that so that it'll work fully with the rest of the system. And then optimization at the far end, so you can take advantage of the libraries, and then there's also some auto-tuning methods that we can apply to that. So what does it look like from a deeper level? You start off with your SYCL code, that Khronos standard SYCL programming. Just as a side note, to get this SYCL, you can start with NVIDIA's CUDA. So if you've got a lot of pre-existing assets sitting in CUDA in the NVIDIA environment, there is a tool that will transfer across your CUDA code and make it transfer it over into SYCL code. And it's a tool that's called Cyclomatic. Cyclomatic is part of the OneAPI download, so that tool is available for free for people to use. So you start off with your SYCL code, you've got your application code in there that will run across onto the CPU, and then you've got your kernels that will be compiled down onto and run onto the accelerator. And there's the construction kit. It sits with the accelerator and gives you all the low-level softwares, the libraries, the kernels. The kernels will go through and wherever possible take advantage of libraries that are already pre-existing within the OneAPI system, the DNN, the BLAST libraries, and it will run across onto there. So you can see that offload of compute-intensive parts of your application here to take advantage of that accelerator. So I said before that we've actually done a reference implementation for RISC-V, taking advantage of the RVV, the vector extension. The simulation, we've created a very simple environment where you've got a few RISC-V processors in there with the RVV. And this can be any host system, on your PC or ARM or RISC-V. And we create this reference implementation so that you can download this for free. It's open source, and you can start playing around with it. A great advantage of this is you start to see what all bits of code are at each level. You can inspect your system. You can start to see the assembly code that's created, the C code, the intermediate representation. You can start to inspect all the different layers throughout the tool chain. And then you can start morphing this to be more like your system, or you can optimize this according to what the application, the algorithm that you're running. So you can start, it's what we call it's software-driven hardware. So you've got your AI framework or your algorithm, and you can start adapting your hardware according to the final software that you're running. So it's a way of optimizing your design. So what's actually in this construction kit? So on the left side, you've got a few of the components. As I said, it started off as an OpenCL implementation. So you've got OpenCL, you've got Vulkan. You see SPIR-V in the middle there. That's a Khronos intermediate representation. You see the libraries. You've got Vex, which is the vectorizer. So that'll take it from from scalar code across onto vector code. And a few other libraries, the math library and the imaging. To ensure conformance and that you've not broken anything, there's a whole set of testing tools sitting on the right-hand side that tests, and we used to use that as our product, but that's now for free, and you can start downloading this and using it and making sure that as you evolve your product, your hardware and your software, you can always check and have regression check and continuous integration with these testing components that are there. So the benefits of OneAPI. Now, this is a construction kit, which is a chunk of code, all the low-level stuff. And then you've got the full ecosystem, but the whole system, what's the benefits of it? Well, you've got high-performance software. Ultimately, you want your accelerator to be part of a system that is giving you very high performance. So you've got that parallel compute from the accelerator, high-quality compilers, efficient language, pre-written libraries, domain-specific optimizations, and I mentioned tuning, and more specifically auto-tuning. There is a way that you can apply auto-tuning to this. Matrix Multiply is the best example here, where there's about half a dozen different algorithms. You can do matrix multiply according, whatever one's best, depending on the matrix that size or this size, on your specific hardware, if it's memory intensive, if it's some latency in different memory systems. So you can do auto-tuning on that. It exposes all the RVV to developers. It means that you can really get down into the guts of this. You can enable and you can do vector-specific extensions. You have full access at all levels to go down there. So chip designers and software developers, they want to see exactly what's going on under the hood. They don't want a black box. You can really get your hands on all the different layers here. There's already a massive pre-existing ecosystem. I'll show you shortly. A lot of companies are involved in here and what the ecosystem looks like. But there's a lot of already pre-existing open sourced material out there. And its hardware can be optimized according to the application that's there. So you can experiment with different architectures, different memory systems, interconnect, changing your algorithm. What does that do? You can start experimenting and see what it's like. So all these components, the two main components there, you see Vectorizer and the MathLib. It's well documented. It's on that web page, and you can see how to do it. And then you can also get your own optimizations in there as well. So there's lots that you can experiment with. It's a perfect playground for you to optimize your system and get to understand what's really going on there. There will be a QR code coming up later with that on there. But you can go to our CodePlay developer portal, and there's a few links there. One will take you to the GitHub, and the other one takes you to all the documentation that was on that previous page there. So lots of information there. Massive ecosystem, lots of companies have been involved in doing things with OneAPI. So you can see this isn't just a new thing. There's already a lot of momentum out there. So that second component I'm going to talk about is UXL, the Unified Acceleration Foundation. It's that chunk in the middle, up above. Once you've done the construction kit, then you've got access to this UXL part. OneAPI, a lot of people have heard of, and whenever I talk to people, they used to say, well, OneAPI is an Intel thing. So we've taken OneAPI and we're taking it out into a foundation, getting other big companies involved in it to make sure it's no longer an Intel thing. This slide is slightly out of order, but here we go. Just to show you that there are companies out there using this. This is NSITEX in Japan. They do an RVV accelerator, and they used it, and they said they're excited that the same technology is available to the open community to make it easier to bring SYCL development for the next generation of accelerators and processors. So they're one of the early adopters, and they very much support the strategy of and the ambition of SYCL and of OneAPI as an ecosystem. So this UXL Foundation was just announced less than 2 months ago. You can see a lot of press coverage there. So it's a foundation, less than 2 months, so we've a lot of publicity, and there are the founder members. So you can see we've got a lot of the industry heavy hitters out there have joined in and to become founder members of this now. Just announced today, there is one other company that I was unable to add to these slides. It was just announced today. I was also nervous about putting it into these slides in case I announced it up on here before the company announced it themselves, is VMware. So VMware is now an 8th company that's just been added to this. So great to have them on board. So you can see really there's a lot of industry momentum growing around this now. So what is UXL Foundation? So I need to read the top line here because I think it's well scripted. A cross-industry group committed to delivering an open standard accelerator programming model, and it's hosted by the Linux Foundation. So you can see the ambitions is to create this standard programming environment for compute systems here. So it really helps both from the top down from software developers and the bottom up for hardware chip designers. From the top down, it means that software application developers are working with a consistent and a well-defined software environment. Software developers, application developers, want that consistency. They don't want to write all their code into a proprietary software stack, a proprietary software environment, and then have to change chip and move on to a different programming environment. This gives a consistent programming environment for software developers. As chip designers, and there's a lot here today, you're working from the bottom up, which gives you a clear target of what your system should be aiming for. And you can optimize your system for that software environment. So it really is solving problems for the software developer and from the chip designer. On the right-hand side, you see the structure, the organization of the UXL Foundation. There's a steering committee with the founders there, but there's a whole bunch of special interest groups and working groups. And it can cover the hardware side of it, so that the construction kit is being morphed according to what is needed by the industry, and all the other layers for the DNN libraries, the SYCL implementation, optimization into things like PyTorch and TensorFlow and ChatGPT. So it's all these different working groups, special interest groups there. So what's been given over to the UXL Foundation? So it started life as one API, which was an Intel thing. You can already see the initial contributions here is a specification and a number of open source projects. The ones that you really take out of this is DPC++. That is one API. That was the SYCL implementation. So there's an open source SYCL implementation that already is donated over to the UXL Foundation. Just as a side note, at CodePlay, let me just come back a bit. Intel created that DPC++ SYCL implementation, and it works for Intel GPUs. At CodePlay, we created plugins so that you can also take that and run that down back onto NVIDIA GPUs and onto AMD GPUs and onto RISC-V accelerators, RVV. And so that SYCL implementation, that single SYCL implementation, will work on already multiple machines. DNN libraries, there's MKL down here, maths kernel library, that contains your BLAS and a few other maths components. So you can already see there's a lot of momentum already in the UXL Foundation to get things started with. We're only 2 months in, and we are building up the momentum here. So making good progress, I would say. So it's already starting with one API. There's already a lot of projects being done with one API already. And if you go into this, awesome one API repo, you can find an awful lot of projects that are tagged with one API. There's too many projects in there for me to even list them on a slide, so there's a lot already pre-existing. So go into the GitHub, and it's listed down the bottom here. Back to the one API construction kit, I said there's a QR code. It's slightly out of order. That's the first part we did, the lower level implementation that you can put onto your RISC-V. There's a QR code that will get you straight to the page that you need to be going to. Last slide, a bit of history here. CodePlay, we've been around for 21 years. We're based in Edinburgh, less than 100 people. Last year we were bought by Intel with the motivation of really expanding that ecosystem around one API and SYCL. And we were responsible for taking this out as a foundation as well. And we also work with cutting edge research so that we're really ahead of the field. A little bit of legal stuff just to finish off with, but really the takeaways that we've got here is get into the GitHub, get onto the one API construction kit and start experimenting with it. You can start to run very high level code and you can start experimenting with your design and start seeing how you can use standards on an RVV accelerator. And I will be reaching out to many companies about UXL Foundation because I want a lot of people to come and join the UXL Foundation, start getting involved in these working groups. You can join for free, but there are other tiers of membership that you can join. And I've also got some cards here of the UXL Foundation if somebody wants to pick one up at the end of this session. That's all for me. Thank you very much, everyone.